Hello, good morning, good afternoon, good evening to all of you. I am John Michael Bon M. Sabala from BS Ed Math 3A, and this is my final project on abstract algebra, also known as M115. So next slide. This is my final project 2 in M115. Next. So let's explore its subgroup and draw a lattice diagram relating the different subgroups. So in here, 'di ba, sa project 1, define natin na group structure yung table B natin, which is yung stellara natin. So dito naman sa project 2, i-explore natin lahat ng subgroups at yung lattice diagram ni stellara, which is yung geometric model po natin. Next slide po. So now this is our table B that contains Roman numerals 1, 2, 3, 4, 5, 6, 7, 8, alpha, beta, gamma, delta, epsilon, zeta, eta, and theta. So this is the improper subgroup of our table, which is table B. So improper subgroups contains Roman numerals 1, 2, 3, 4, 5, 6, 7, 8, alpha, beta, gamma, delta, epsilon, zeta, eta, and theta. So as you can see, all the elements is the improper subgroup of this table. So now let's talk about the proper subgroups. Let's enumerate it. So subgroup 1 is Roman numerals 1 and 5 under the binary operation star. Next, subgroup 1 and alpha under the binary operation star. Subgroup is Roman numerals 1 and beta under the binary operation star is a group structure. Next, subgroup Roman numerals 1 Roman numerals 1 of and gamma under the binary operation star is a proper subgroup. Next, Roman numerals 1 and delta under the binary operation star is a subgroup. Next, Roman numerals 1 and epsilon under the binary operation star is a subgroup. Next, Roman numerals 1 and eta under the binary operation star is a proper subgroup. And lastly, Roman numerals 1 and theta is proper subgroup under the binary operation star. So next one, that contains 4 elements. The proper subgroups are the set of Roman numerals 1, 3, 5, 7 is a proper subgroup under the binary operation star. The set of 1, 5, alpha, and epsilon is a subgroup under the binary operation star. The set of 1, 5, gamma, and eta under the binary operation star is a proper subgroup. And lastly, the Roman numerals 1, 5, beta, and eta is proper subgroup under the binary operation star. So ito pa po, may natira pa. So the set of 1, 5, eta, zeta, and 1, 5 beta and zeta under the binary operation star is a proper subgroup. 1, 5 gamma and theta under the binary operation star is a proper subgroup. And now that contains subgroup that contains 8 elements are the following. Number 1 is the set of 1, 2, 3, 4, 5, 6, 7, 8 under the binary operation star is a proper subgroup. 1, 3, 5, 7 alpha, beta, gamma, and delta is a proper subgroup under the binary operation star. And lastly, the improper subgroups is the set of 1, 3, 5, 7 epsilon, zeta, eta, and theta is a proper subgroup under the binary operation star. So the last one is the trivial subgroup. The trivial subgroup, also known as the identity, contains only one, which is the set of 1 under the binary operation star is a trivial subgroup. Next. So now B1 is improper is a proper subgroup of B. It is grouped because it is closed, it is associative, and identity element exists as well as inverse element exists. So is it true that it is closed? Yes. Why? Because if we flip the table, we can get the same pwesto ng mga elements po natin. So in that way, we can say that this table is associative. And lastly, identity element exists. Yes, meron pong identity element dito, which is yung Roman numerals 1. So as well as the inverse. So let's define what is the inverse of Roman numerals 1 and 5 in this video, in this subgroup. So the inverse of 1 is 1. So as you can see, may Roman numerals 1 po dito, tas yung nasa column po niya is 1 din sa taas. That's why is itself, the inverse of 1 and 5 is itself, because nakatutok po yung Roman numerals 1 or pa-diagonal po yung Roman numerals 1 po natin dito sa figure po na ito, subgroup po na ito. Okay, so I hope you get it. So B1 has the same binary operation star with B. Yes. So next one is B2 is a subgroup of B. Yes, it is a subgroup of B. Why? Because it is closed. It is closed. Yeah, because po yung mga nasa loob lang po nung table na to is A po yun, hindi po yun I na typo po. Alpha po yun. Alpha po yun nasa tabi po nung alpha at nasa baba po nung alpha sa column. So closed po siya kasi po alpha and Roman numerals 1 lang po yung lumabas. It is associative. Yes, associative po siya kasi po pag linif po natin yung table, yun pa rin po at yun ang lalabas sa outcome po natin. Alpha and Roman numerals 1 lang din po talaga siya. So last, identity element exists as well as inverse. Yes. Why? Because una, identity element natin, paulit-ulit na po natin sinasabi na yung identity element natin is diagonal. Diagonal po yung identity element natin. That's why we can say that identity element exists kasi nag-exist po siya diagonally. That's why we can say that the inverse element of alpha and Roman numerals 1 is itself. So B2 has the same binary operation star with B. So the the subgroup Roman numerals 1 and beta under the binary operation star. B3 is a subgroup of B. Yes, kasi galing din po ito sa table B po natin. It is a group because una, it is closed. Yes, because yung outcome po nung dalawang nasa table po natin na element is Roman numerals 1 and beta lang po talaga siya. Kaya po close po siya. Next po is yung it is associative. Yes po, because kahit baliktarin pa po natin yan, trinay ko na po siya ng paulit-ulit. And yes, same pa rin po yung outcome niya. That's why we can say that this table is associative. And lastly, identity and inverse element exists. Yes, because our Roman numeral 1 is placed diagonally. That's why we can say that Roman numerals 1 and beta is inverse of itself. The inverse of Roman numerals 1 is 1 and the inverse of beta is beta. That's why we can say that B3 has the same binary operation star with B. So next one, Roman numerals 1 and gamma under the binary operation star is a proper subgroup. So B4 is a proper subgroup of B. Why? Because it is grouped because first one, it is closed. Yes, it is closed because all the partners, if we partner Roman numerals 1 star y, the answer will become gamma. That's why closed siya. Okay, so it is closed. And then it is associative. Yes, because if we flip this table, we can get the same value as this table. So in that way, we can define that this table is associative. And lastly, identity element exists as well as inverse element. Yes, because our Roman numerals 1 formed diagonally. That's why we can say that the inverse element of this table is itself. For example, the inverse of Roman numeral 1 is equal to 1, and the inverse of gamma is also gamma. So we can say that B4 has the same binary operation star with B, or table B. Next, the set of 1 and gamma under the binary operation star is a proper subgroup. B5 is a proper subgroup of B. Why is this a group structure? It is group because it is closed. Why? Because all of the elements in this set contains only the elements of it. Like for example, only Roman numerals 1 and gamma is in the outcome of these two elements. That's why it is closed. Okay, it is associative because if we flip this table 180 degrees and then we rearrange it in order, we can get the same value as this table. So in that way, we can say that this table is a associative, is an associative. Next, identity and inverse element exist. Yes, because the identity element 1, Roman numerals 1, exists in this table. The identity element Roman numeral 1 exists diagonally in this table. So in inverse element, we can say that the inverse of each other in this table is themselves. So for example, the inverse of Roman numerals 1 is 1, and the inverse of gamma is also gamma. So next one, we can say that P5 has the same binary operation star with B or table B. So next one, the set of 1 and epsilon under the binary operation star is a proper subgroup. This is the B sub 6 is a proper subgroup of B. Yes. Why is this a group structure? This is a group structure because it is closed. It is closed as I said earlier that the outcome of when we paired do nothing to epsilon, the always outcome of it is also epsilon. That's why it is closed. Okay, because all of the elements contains, all of the outcomes contains only from the elements that we used. Okay, so it is closed. Associativity, yes, it is associative because if we flip this table 180 degrees, we can get the same positioning of the elements as the original. So in that way, we can define or we can determine that this table is associative. Okay, so last, identity and inverse element exist. As I said earlier, the identity element Roman numerals 1 is placed diagonally. That's why it existed. Okay, so the inverse element of each other, since Roman numerals 1 is placed diagonally, we can say that the inverse of epsilon and Roman numerals 1 is themselves. For example, Roman numerals 1, the inverse of Roman numerals 1 is 1, and the inverse of epsilon is also epsilon. So we can say that B6 has the same binary operation star with B. Next, Roman numerals 1 and delta is a proper subgroup under the binary operation star. So B7 is a proper subgroup of B. It is a group because it is closed, it is associative, and identity and inverse element exist. So it is closed since all of the elements delta and Roman numerals I is in this table. Walang iba, delta and Roman numerals 1 only. So in that case, we can say that this table is a associative. It is a closed. Next, associativity. So it is associative because when we flip this table 180 degrees, as I said earlier, we can get the same as the original. That's why we can say that this table is also associative. And lastly, identity and inverse element exist. Identity element I existed in this table, so identity element exists. And lastly, inverse element. The inverse element of Roman numerals 1 and delta in this table is themselves. That's why inverse element existed in this table. So we can say that B7 has the same binary operation star with table B. So next one, the set of Roman numerals 1 and zeta. Ay, hindi pala. Eta na pala to. Eta po pala. Eta. So B sub 8 is a proper subgroup of B. Yes, because table B contains eta and Roman numerals 1. It is a group because it is closed. Yes, because the outcome of each element in this table is closed, like it belongs to themselves. So, itself din po, sila din po mismo yung belong here in this table. For example, I star I is I, and Roman numerals 1 star eta is eta. So, themselves existed in this table. That's why it is closed. It is associative because when we flip this table 180 degrees and then rearrange the table, we can get the same as this original table. So in that way, we can say that this table is associative. And lastly, identity and inverse element exist. Yes, identity and inverse element existed in this table. What is the identity element? The identity element in this table is the Roman numerals 1. So the inverse element in this table are the inverse of Roman numerals 1 is 1, and the inverse of eta is also eta. That's why inverse element exists. Therefore, we can say that B8 has the same binary operation star with B. So now let's have the subgroup of the set of 1, 5, 3, and 7 is a proper subgroup under the binary operation star. So B10 is a proper subgroup of B. Yes, because the element of this table contains from the table B. So this is grouped because it is closed. Why? Because the outcomes of each pair in this table is themselves. That's why it is closed. For example, 5 star 3 is 7, and 7 is in this table. That's why it is closed. Okay, because it contains the answer of this table contains each element. Okay, so it is associative. Yes. Why? Because if we flip this table 180 degrees, we get the same value as this table. If we flip it 180 degrees and rearrange it in order, so it has the same value as the original. That's why we can say that this table is associative. And lastly, identity and inverse element exist. Yes, because identity element is placed diagonally in this table. So in that way, we can say that the inverse element of each element in this table contains themselves. For example, the inverse element of 1 is 1. The inverse element of Roman numerals 5 is 5. The inverse element of Roman numerals 3 is 3. And lastly, the inverse element of Roman numeral 7 is 7. That's why we can say that this table is a group structure. So therefore, B10 has the same binary operation star with table B. So next. So now let's have the set of 1, 5, alpha, and epsilon under the binary operation star is a proper subgroup. So B11 is a proper subgroup of B. Yes, because the element of this table contains on the table B. So it is grouped because it is closed. Yes, why? In what way? Because the outcome of each element of this table is themselves. So, for example, V star alpha is epsilon. Epsilon is in this table, is in this set. That's why we can say that this table is closed. Okay, so Now, let's have the associativity. Associative, it is associative because when we flip this table 180 degrees, then rearrange it in order. So, for example, we flip it 180 degrees, then arrange it from 1, 5, alpha, and epsilon. We can get the same as this table. So, in that way, we can say that this table is associative to each other. So, the flip table and the original table has the same. So, in that way, we can say that this table is associative. And lastly, identity and inverse element exist. Yes, the identity element in this table is the Roman numerals 1. The Roman numerals 1 is placed diagonally in this table. So, in that way, we can say that the inverse element of each of the element in this table is themselves, because the identity element is placed diagonally. For example, the inverse of 1 is 1, the inverse of Roman numerals 5 is 5, the inverse of alpha is alpha, and lastly, the inverse of epsilon is epsilon. So, in that way, we can say that B11 has the same binary operation star with table B. So, next one, the set of 1, 5, gamma, and eta under the binary operation star is a proper subgroup. So, B12 is a proper subgroup of table B. Yes, because all of the elements in this table contains from table B. It is grouped because it is closed. Yes, as I said earlier, this is grouped because all of the elements, all of the outcomes of this element is themselves. That's why it is closed. It is associative, yes, also because it is associative because when we flip the table 180 degrees, as I said earlier, then rearrange it in order 1, 5, gamma, and eta, we can get the same value as the original. So, in that way, we can say that this table is associative. And lastly, identity and inverse element exist. Yes, because the identity element, Roman numerals 1, placed diagonally in this table. So, in that way, we can say that the inverse element in this table is themselves because the identity element Roman numerals 1 is placed diagonally. So, as you can see, the Roman numerals 1 inverse is itself the Roman numerals 5. 5's inverse is 5 also. The inverse of gamma is gamma, and lastly, the inverse of eta is eta. So, therefore, we can see that B12 has the same binary operation star with B. Next one, the proper subgroup that contains 8 elements. So, in this, the set of 1, Roman numerals 1, 2, 3, 4, 5, 6, 7, and 8 under the binary operation star is a proper subgroup of B. So, B13 is proper subgroup of B. It is grouped because it is closed. Yes, it is closed. Why? Because no pair in this table answers alpha, beta, gamma, or anything around the element 9th element to 16th element. So we can say that this table is closed because the outcome of each pair is themselves from 1 to 8 only. Next one, identity and inverse element exist. Yes, identity element and inverse element exist in this table, but the inverse of this table is not themselves. Why? Because the identity element is not placed diagonally. It's not placed diagonally as the same as the Roman numerals 1. So the Roman numerals are placed like lefty. Okay, so let's define what the identity element is in this table. So the identity element in this table is the Roman numerals 1. Okay, so the inverse element of each element in this table are, for example, the inverse of Roman numerals 1 is 1. The inverse of Roman numerals 2 is 8. Why? Because the Roman numerals 1 is at the tapat of Roman numerals 8. Okay? So that's why we can say that the inverse element of Roman numerals 2 is 8. So the inverse element of Roman numerals 3 is 7. The inverse of Roman numerals 4 is 6. The inverse of Roman numeral 5 is 5. The inverse of Roman numeral 6 is 4. The inverse of Roman numerals 7 is 3. And lastly, the inverse of Roman numerals 8 is 2. So, as you can see, nagpalit-palit lang sila. Like, yung inverse nila nung 2 is 8. Yung 8 is 2, di ba? Nag-interchange lang, nag-swap lang sila. Okay? So, we can say that B13 has the same binary operation star with B. Okay? So, next proper subgroup na po natin is the set of 1, 3, 5, 7, alpha, beta, gamma, delta. Under the binary operation star is a proper subgroup. So, B14 is a proper subgroup of B. It is grouped because it is closed. Yes, closed po siya. As I said earlier, the outcome of this table is themselves, not the other elements that doesn't exist in this table. That's perfect. So, it is closed because yon outcomes po nila is sila-sila lang din, hindi po yung ibang elements. It is associative, yes, because if we flip this table 180 degrees, then we arrange it in order, we can say that the flipped table is congruent to the original table. So in that way, we can say that this table is associative to each other. So this table is associative. And lastly, identity and inverse element exist. Yes, because as you can see, the identity element 1 placed diagonally in some point, but in Roman numerals 3 and Roman numerals 7 part is not in diagonal place, but that's okay because it is subgroup also because identity and inverse element exist. For example, the inverse of 1 is 1, the inverse of 3 is 7, the inverse of 5 is 5, the inverse of 7 is 3, the inverse of alpha is alpha, the inverse of beta is beta, the inverse of gamma is gamma, and lastly, the inverse of delta is delta. So in that way, we can say that the inverse element and identity element existed in this table. So therefore, B14 has the same binary operation star with table B. So lastly, in proper subgroup, we have the set of 1, 3, 5, 7, epsilon, zeta, eta, and theta. So B15 is a proper subgroup of B. Yes, because all of the element in this table is contains from table B. It is a group because it is closed, yes, because all of the outcomes in this table is themselves only, not the other element that doesn't exist in this table. It is associative also, yes, because when we flip this 180 degrees and rearrange it in order, we can get the same value as this table. And lastly, identity and inverse element existed in this table, yes, because the identity element 1, Roman numerals 1, existed in this photo. Then the inverse element of each element in this group are the following. The first one, the inverse element of 1 is 1. The inverse element of 3, as I said earlier, it's 7. The inverse element of 5 is 5. The inverse element of 7 is 3. The inverse element of epsilon is epsilon. The inverse element of zeta is zeta. The inverse element of eta is eta, and lastly, the inverse element of theta is theta. That's why we can say that the identity and inverse element in this table existed. So we can say that B15 has the same binary operation star with B or table B. So the trivial subgroup, the set of 1 Roman numerals 1 under the binary operation star, is a trivial subgroup of table B. B16 is a subgroup of B. It is grouped because it is closed. It is associative, syempre. And lastly, identity and inverse element exist. Yes, common sense na lang po yan. So B16 has the same binary operation star with B. So this is a lattice diagram showing the different subgroups of the group P of stellara table. So group B is equal to the set of 1, 2, 3, 4, 5, 6, 7, 8 alpha, beta, gamma, delta, epsilon, zeta, eta, and theta under the binary operation star is a group structure. So there are three elements there are three subgroups that contains 8 elements based on this table, which is B13 is equal to the set of 1 to 8 under the binary operation star is a proper subgroup, and B14 is equal to the set of Roman numerals 1, 3, 5, 7 alpha, beta, gamma, and delta under the binary operation star is a proper subgroup. And lastly, in 8 elements, we have B15 is equal to the set of 1, 3, 5, 7, epsilon, zeta, eta, and theta under the binary operation star is a proper subgroup. So in this, we have 3 elements that contains 4 elements, that we have 3 subgroups that contains 4 elements in this table. So B10 is equal to the set of 1, 5, 3, and 7 under the binary operation star is a proper subgroup. B11 is equal to the set of 1, 5, alpha, and epsilon under the binary operation star is a proper subgroup. And lastly, B12 is equal to the set of 1, 5, gamma, and eta under the binary operation star is a proper subgroup that contains 4 elements. So we have 7, 2, 4, 6, 8, 9. So we have 9 elements that we have 9 subgroups that contains 2 elements in this table. So we have B1 is equal to the set of 1, 5 under the binary operation star is a proper subgroup. We have 1 and the set of Roman numerals 1 and alpha under the binary operation star is a proper subgroup. Next, the set of 1 and beta under the binary operation star is a proper subgroup. Next, the set of 1 and gamma under the binary operation star is a proper subgroup. Next one is the set of 1 and delta is a proper subgroup under the binary operation star. Next, the set of 1 and epsilon is a proper subgroup under the binary operation star. Next, the set of 1 and zeta under the binary operation star is a proper subgroup. And next, the set of 1 and eta is a proper subgroup under the binary operation star. And lastly, the set of 1 and theta is a proper subgroup under the binary operation star. So, and lastly, our trivial subgroup is B16 or B sub 16 is equal to the set of 1 Roman numeral star Roman numerals 1 under the binary operation star is a trivial subgroup. So, that's all for today. Thank you for watching and I hope you learned something new po. Thank you po.